Okay, what if I told you that the entire purpose of science, the one we all learned in school, is just wrong? That's the pretty mind bending idea we're diving into today. And it comes straight from physicist David Deutsch's incredible book, The Fabric of Reality. Seriously, this one idea could completely flip how you see everything, from something as simple as the common cold all the way to parallel universes. So ask yourself this: what's the real goal of science? I mean, what's it all for? Most of us would probably say to make predictions, right? To forecast what's going to happen. But what if that's only half the story? Or, even crazier, what if that's the wrong half? And here it is, the big showdown. On one side, we have the idea that science is all about prediction, just forecasting what's going to happen next. But on the other side, David Deutsch makes a case for something way deeper: explanation. He argues it's not enough to just know what's happening. The real game, the true purpose of science, is to understand why. Okay, so you might be thinking, prediction, explanation, what's the big deal? Well, this distinction is actually huge. And to show you why, let's walk through a fantastic example of a theory that's perfectly predictive, but at the same time is completely and utterly useless. And it all comes down to that missing piece: a good explanation.
All right, get ready for this one. It's a thought experiment from Deutsch himself. Imagine a theory that says eating a kilogram of grass is a cure for the common cold. Now, I know, that sounds totally ridiculous. But here's the kicker. In one really important way, it's a perfectly scientific theory. Why? Because it makes a specific, testable prediction.
Okay, so if it's a testable theory, why has no one ever actually tested it? I mean, you don't see scientists out in fields gathering grass for clinical trials, right? So what gives? The answer to that question, well, it gets us right to the heart of what science is really all about. And here's the punchline. The reason we instantly throw this idea out isn't because someone tested it and it failed. Nope. It's because it has absolutely zero explanation. It doesn't tell us how it would work. There's no mechanism, no reason why grass would do anything to a cold virus. And this is a huge insight. A massive part of science is just filtering out bad explanations, and most of them get tossed in the trash long before anyone even thinks about setting up an experiment. So what's the difference between a good explanation and a bad one, like the grass theory? Well, a good explanation isn't just a rule of thumb. It gets at the why. It's about describing the inner machinery of reality. Think of it like this. A good explanation is tight. It's elegant. You can't just change one part of it without the whole thing falling apart. It's got this coherence that gives it real power. Now, this whole idea of demanding a good explanation, one that's hard to just mess with, it's not just some philosophical rule. It's a powerhouse of a tool. And when you apply it to the real world, oh man, it leads us somewhere absolutely wild. It actually forces us to face what looks like a glitch in the matrix, a deep mystery hidden in the weird world of quantum physics. So let's do it. Let's take this tool and apply it to a real-life experiment. And you'll see, just by sticking to our guns and demanding a good, solid explanation for what we see, we get pushed, logically, to a conclusion that sounds like it's straight out of a sci-fi movie. But it's not fantasy. It's based on cold, hard observation. Okay, buckle up, because this is where reality starts to feel a little wobbly. Just follow the logic, step by step. 1, we fire a single particle of light, a photon, and it goes through just one slit. We know this for a fact. 2, here's the crazy part. Where that photon lands is somehow affected by whether the other slits are open or closed. Think about that. Which leads us to an unavoidable conclusion, step 3, something else has to be coming through those other slits and messing with our photon. And the final, mind-blowing step 4, whatever these interfering things are, they act exactly like photons, except we can't see them. They're invisible.
So what do we call these invisible things? Deutsch gives them a name that's perfectly spooky: shadow photons. Their only footprint in our world is the way they push around the one photon we can see. It's like seeing the effect of a ghost. So the billion-dollar question is, where in the world are they coming from?
And this is where our demand for a good explanation pays off in the most spectacular way. Because the only good explanation we have leads to a conclusion that is absolutely staggering. So those shadow photons, where are they? Well, the only explanation that doesn't force us to throw logic out the window is this. They are actual, real photons. They're just in other parallel universes. universes that are every bit as real as ours, and apparently so close that their particles can literally reach across and interfere with ours. This whole cosmic web of realities, that's the multiverse. And it's really crucial to get this next part. This isn't just some fun sci-fi trope. The multiverse isn't a wild guess. It's the destination you arrive at when you follow the map of logic. When you demand a real, rational explanation for the physical interference we actually see in the lab, this is where you end up. It is, quite simply, the best explanation we've got. But here's where it gets even bigger. This powerful idea that all progress is really about finding better and better explanations, it's not just for quantum physics. It completely flips our understanding of how we learn anything at all, how knowledge itself actually grows. Just like we started with that myth about science being just prediction, there's another common myth about how we learn. It's called induction. It's the idea that we just wander around, collect a bunch of data, and poof, a theory just emerges from the pile. But the reality, it's way more exciting and active than that. We learn by solving problems. We bump into a problem, we dream up a bold, creative explanation for it, and then we try our absolute hardest to prove it wrong. And that cycle right there, that's the real engine of all progress. It doesn't start with a boring observation, it starts with an interesting problem. Then comes a creative spark, an inventive guess, a conjecture. But then comes the most important part, criticism. We attack the idea from every angle, trying to break it. And the explanation that survives that trial by fire, well, that becomes our new best understanding, at least for now. And then, of course, it just leads to new, even more interesting problems. So you see, knowledge isn't something that's just distilled from data, like squeezing juice from an orange. No, it's forged. It's hammered out in the fire of criticism. Our theories are these incredible creative inventions designed to solve problems. And the ones we hold on to are simply the ones that have survived the toughest battles. And this all brings us back to that amazing title, The Fabric of Reality. Because what Deutsch is really saying is that all these big ideas, physics, how we learn, even evolution, they aren't separate subjects in different textbooks. They're all just threads woven together into one single unified fabric, a reality that, at its core, can be understood. And the way we understand it is through that relentless search for good explanations. So what's the big takeaway here? What does all this mean for us? Well, first, the goal of science isn't just to predict things. It's to achieve a deep, genuine understanding. Second, that quest for understanding shows us that reality is so much bigger and so much stranger than it looks. We're talking parallel universes, people. Third, knowledge doesn't grow by passively collecting facts. It grows by actively and creatively solving problems. And finally, all of it, all these different fields of knowledge, are connected by this beautiful web of explanations. Which, of course, leaves us with one last huge question to chew on. This relentless search for better explanations has taken us on an incredible journey, from a silly idea about grass all the way to the multiverse. It's completely changed the game for how we think about knowledge itself. So if reality really is this beautiful, complex fabric, as we keep pulling on the threads, what incredible new layer are we about to uncover next?